So today's lecture is on the quicksort algorithm. This is a recursive algorithm. It's one of the best algorithms out there. It's very fast. And if you look back, I included some of the sub algorithms in there, some of this, partial coding. This is the way this algorithm works. Okay, it picks the first number here, that's a 10. We're going to make that the pivot. So what we're going to do, we're going to go from left here to the right and find the first number that's greater. In this case, we found 16. We're going to go from the right to the left. We find the first number that's less than. We found 9. Remember, if I use I as a subscript, I use J as a subscript there. So J always has to be greater than or equal to I. Now, this is 16, first number is greater than 9, first number. I'm going to swap those two. So I'm going to do 9 and I'm going to include 16. Okay, so far so good. Let's try it again. Let's go from the left to the right. First number that's greater than 10. We go right to the left. First number that's less than 10. So in this case, we found 12 and 3. So we're going to swap the 12 and the 3. Okay, we're going to continue. Okay, so first number that's greater than 10 is 15. We go right to left. First number is 6. So I'm going to swap the 6 and the 15. So we can do this as long as I is less than or equal to j. Continue again. First number that is greater than 10, the pivot, is 15. First number that's less than the pivot is 6. Well, in this case, I becomes less than j, which is not, j becomes less than I, which is not acceptable. So I will swap the pivot with 6, okay? So I'm going to bring down all the other values. So in this case, I have 15 here, I have 12, I have 16, 20, 19, and 17. So as you can see, the pivot 10, every number on the left is smaller, every on the right, number on the right is greater. I'm going to take this as a subtree. I'm going to start the same process. Let's pick 6 as the pivot. First number that's greater than 6 is 9. First number less than 6 is 3. So I'm going to swap the 9 and the 3. Okay? So to continue. First number that's greater than 6 is 8. First number is 3. So j is now, if this was I and this is j is now less than I. So I'm going to take this smaller number, which is 6, the pivot, I'm going to swap it with 3. Then I have 8 and 9. Now, if I look at the subtree of the pivot, there's only one element, one number. I'm going to leave it. On the right, okay, so I go this way, find the first number, so I'm going to take 8 as the pivot. First number that's greater than 8 is 9. There is no number less than 8, so I will leave 8, so make it as part of the sorted number. Then I'm going to go to my right subtree, that's why this is recursive. I'm going to take 15 as my pivot. First number greater than 15 is 16. Well, I'm going to go from the right. First number that's less than 15 is 12. See, this is j and this is I. J cannot be less than I, so I'm going to swap the 15, that's the pivot, and 12. And then bring down the rest of the values, the numbers, the integers. Okay. The left subtree of 15 only has one element, so I'm going to leave it as it is, so that's the number. So now, so there's not the subtree here is just 12. To the right, there is 16, 20, 19. So I'm going to take 16 as the pivot. I'm going to go this way. First number that's greater, since it's 20. First number that's less than There is none, so I can't find any. So therefore, I'm going to leave 16 as it is. Now, the left subtree of 16 is null, so there's nothing there. Well, the right subtree has 20, 19, and 17, so I'm going to take 20, 19, and 17. I'm going to pick up 20 as the pivot. First number that's greater, I can't find any, so none. Well, then I found 17 as the smaller number. Since it's a smaller, I'm going to swap those two. So I'm going to make the 20 on this side. Okay? I swap those, so since there's no left subtree, so this is 19. Now I have two numbers. I have 19 and 20. Okay? First number is greater, is 20. No number less than, so I'm going to include it as part of the tree. So now go back to my list. I have 3, I have 6, 8, 9, 10, 12, 15, 16, 17, 19, and 20. See, this is the sorted list from the original list. So it is known as the quick sort, and it uses recursive. It has a tree, binary tree, left and right. So if I look back here, 3, 6, 8, 9, 10, 12, 15, 16, 17, 19, and 20. And we're done. Thank you.